Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Going Beyond BIM to Achieve Digital Twin. My name is Amanda and I will be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Hexagon. Hexagon is a global leader in sensor, software and autonomous solutions. They put data to work to boost efficiency, productivity and quality across industrial, manufacturing, infrastructure, safety and mobility applications. The company's PPM division empowers its clients to transform unstructured information into a smart digital asset to visualize, build and manage structures and facilities of all complexities, ensuring safe and efficient operation throughout the entire life cycle. Today we will hear from our three speakers, followed by an audience Q&A session, and I encourage you to send questions through to our speakers via the YouTube chat box as the presentations roll out. I'd now like to welcome our first speaker for today, Sean Webster. Sean joined the Laing O'Rourke in 2018 and is currently the Principal Digital Engineer managing the team for the Sydney Metro projects. Sean is responsible for delivering on Sydney Metro digital engineering requirements and implementing a consistent standard of digital and information management to drive productivity and digital enablement. Before joining Laing O'Rourke, Sean had worked on the client side at Transport for London as part of the core BIM team, delivering the digital framework and the first iteration of the common data environment to projects and programs. Sean is passionate about the implementation of a consistent approach to data management, enabling clear, consistent data outcomes for all areas of the construction industry. Please welcome Sean Webster.
Thanks, Amanda, for the introduction. It's great to be here, and thank you for having me to present to everyone on Engineers Australia. So I'll be going through this. So we're going to be talking about going beyond BIM to achieve digital twins. And let's start the session. So we'll just go next. What I'm going to talk about actually going through is how this actually applies to the constructor, and then what the methodologies are. So first hitting what's a digital twin, how it actually works, going through the setup, about information management and what we have to do to actually achieve this. Then going through integration of systems and the life cycle of how that actually works. And then what does that actually give us at the end? So some examples of how we've achieved some great innovations, but also some outcomes connecting our data and how that's actually enabling people in the workforce. So the first one I was talking about is the asset lifecycle. So digitization of the physical assets. So what does this actually mean? Well, this is actually what we're here to talk about. It's about the digital twin. So in the images here, you can see that there's actually three different types or three different areas we could actually talk about digital twins. So the first one here is about the constructional design phase. So you can see the top left-hand corner, or the left-hand corner for me, is the actual digital representation of utilities under a busy road, actually in London, a project I worked on many years ago. But here it's actually congestion. So we have to understand what's existing and what's new, and how do we actually build in that environment. So preventing clashes, preventing utility strikes, and how do we go around making sure that we've engaged with all the different stakeholders and understanding what's actually out there so we can successfully build that project. The one on the top right-hand corner is then actually during the construction phase. Here we're actually talking about what have we actually done and how does it actually look inside the design. So the comparison between what is the virtual and what is actually the physical and what we have actually done. I go over this a bit later in the session because this is actually some of the stuff we've been doing with interface and stuff like that. But you got to remember that's actually part of this whole process. We're going to show what we've actually constructed is actually what we've actually gone to design to make sure it goes over to the client. And finally, it goes into the actual asset maintenance or the operation of the asset. So how do we actually start doing that during the design phase as well as going to construction? How do we test out buildings and test out our assets to make sure that these are actually going to operate like we think they are, so we can actually virtually run these systems before we even actually turn a key or we actually put a shovel in the ground. So this is what we're going to go through today. But I want to touch back on actually this part here. So the actual asset lifecycle, the information lifecycle that we actually have. So it's important here to remember that when an asset or the lifecycle that we talk about, the construction phase, is quite a small section of the work. Information is key when we actually talk about the full asset lifecycle. So in this image, we can see that at the start of it, we actually have project development. So in this phase is where the clients will define what the requirements are, what their business rules are, and what they're actually trying to meet with this project. And during this phase, we'll hand that over to contractors and designers who will actually build up this design and make what's called the project information model. So the first pass of this data. And it's during this stage we actually build the first asset information model and hand back over to operations. And that's where we're focusing about today. But here we're actually talking about here is the asset information model. So this is the data that we've got to try to avoid, or we get a lot of rework and wastage. So here with the digital twin, we're trying to make sure that we've got the data, we know it's validated, and we can reuse that information so we can quickly get there and do some minor work. So how do we get there and go, we need to actually replace these parts and equipment, or we need to upgrade our assets. So how do we quickly give that across to contractors? They can do the work and update what they require. Secondly, you can go through major work. So you might actually include a new concourse or a new platform, or a new section of the road. So how does that actually work? How do we interface with it? And we actually reduce the workarounds or the work that we have to do to make sure we can actually quickly upgrade our assets to continually make sure we're meeting the ever-changing environmental requirements and social requirements and stuff like that. So it goes through this whole process, and actually at the final end, the decommissioning. So we now have to think, because we're in the session about environmental impact and sustainability, and so how do we then get there and use these assets we're building now as like in terms of the sustainable banks? So how do we reuse the material we're using now in the future to build new assets? So this whole asset or information lifecycle is critical, so we actually map that. So part of the digital twin is not just a pretty picture, but it's all about the information that sits beneath it, and how do we get there and optimize this to reduce rework, make sure it works for us in the future. And this actually then gives us one next thing here is around the connected community. So we want to make sure assets are smarter. So how do we make sure they're self-healing? How do we make sure they're meeting our social requirements in the future? And we can actually make sure that people are going to get there. They know that they can go from Sydney to Melbourne, and they know that they can meet people there for dinner or lunch and stuff like that. And how do we actually make all this talk together? So we actually have this smart information or the community structure in terms of that there. So this is how the bigger picture of a digital asset. So yes, we're talking about it from a construction point of view and an operations point of view, but there's also a social impact. So how do we make sure that we're meeting the social requirements in the future? Excellent. So what underpins this? And this is where I'm really interested in myself, is about information modeling. So this is the connected project ecosystem. So we're going to define the data management. So this is how the basic or the building blocks. And traditional approach is this. So we get there, we make drawings, we do separate things in silos. We have coordination that follows the design in terms of it gets to submitted, then we do the coordination. There's gaps because we don't actually define our interfaces correctly without that, because we're not using the actual models and we're not using that sort of 3D concept, trying to build that virtual environment as we're going along. And also there's contracts in terms of how actually the contracts that we sign up to also are sort of rigid around how we actually should do this. We stop it here. We don't actually try to integrate the other different people or processes inside that. So how do we get there and change that? So that's the traditional approach. So the secondary approach here is digitally enabled. So this is where we're talking about a single source of truth, that digital twin. So how do we actually get that information? Everyone knows where that source of truth is. We all can connect to it. We can do what we need to do. We break down those silos. So we know, I know what I need to do for something that you need to complete as well. So through this process, it's all visible. So we understand about the changes, the processes that we need to do. We understand what change there will impact another interface contractor, or actually ultimately the client needs and stuff like that. So the client changes something, it all trickles down. We understand how that all works. Then ultimately we want to get rid of paper. We've been saying this for many years. One day we'll get there, but it'll be awesome if one day we get there and it's a paperless project. So how do we get there and make sure that we use this digital technology as best we can, reducing our sustainable waste, but also that abortive work, because once you print a piece of paper off, that's it. It's out of date straight away. So how do we change that? That's a digitally enabled process. And part of this process is this. It's a common data environment. And if you've been around digital engineering or BIM, you would have heard this quite a lot of times. And the reason why I'm touching on this is, or the reason why this is so important is, you can see here the bullseye on the left-hand corner. So stuff happens, we make some content and information gets created. Fantastic. And in this modern day and age, information can be created in rapid process. Like everyone can create content. I create this presentation, that's the stuff here. All this information gets created in a massive content, massive speed. And then all of a sudden it's published. So has it gone through the correct processes? Have we followed that process? That's why it's blacked out in the middle there. So something's happened. So what's this mean? So, well, if we don't know what's happened in between, it's increased costs, it's increased risks. Like, do we know if this is actually validated? Should I go build off this? And if I do build off this, am I going to duplicate my work? Because I'm going to have to go back and do changes and stuff like that. It causes delays. So handover issues. So do we have all the information? Yes or no? Do we have that traceability through the phase of the life cycle? And that assurance too is like, did we actually do what we've said to do? So have we gone out and do that? And the value stage. So value for contractors is the same process. We need to hand over an asset that's going to meet the client's requirements. If we're missing that link, we get hit because we don't have that value. We're missing the information. We're going to delay, so it costs us. But from a client point of view, it means that it could be actually an asset may not be performing as they expected because they don't know if it's actually correct of what has been requested. Additionally, then it might be actually they have to go straight into a maintenance cycle because it might have been built correctly, but the information or the way it was defined in that whole life cycle wasn't actually going to get there and achieve their outcomes from that, than the bigger picture. So what do we have to do to fix this? So first of all, we have to talk about a project ecosystem. So the current state's left-hand side, this has been supplied by Transport for New South Wales. So working across those projects currently with the Sydney Metro projects from Langarook. And the current state, as you've viewed, everything's in silos. So first thing we have to do is move to that future state where we actually get them, we're going to start talking to each other. So all information needs to be connected. We need to understand what someone else needs and how my information or your information will impact me or and vice versa. So we start breaking that down. And we start getting there and creating and reducing the silo of me creating a report or a database or an Excel spreadsheet. Everyone loves an Excel spreadsheet. And constantly creating that content that we actually then have these silos of information. So that's where the future state comes into it. And that means in the right-hand side, you get people that are much more engaged and understand what they've got to do. So where this come from is this sort of stuff here is a common data environment. So it's understanding what this is. It's not just a single system, it's an ecosystem of data. So this is how it underpins the digital twin. So the representation is graphical, but beneath this, you have this ecosystem of systems. It's all connected and people understand what they've got to do when and how in each system. And then there's actually understanding the touch points with other clients or interface contractors as well. So you have to have that defined within the common data environment. Moving forward with inside that is actually then the data owners and data inputs. So this again is important. It's great saying that we're going to have this system and that system and that system, but then who actually owns the data inside each one of those systems and who owns the inputs. So it's quite a technical challenge when you go through and you have to map out all the actual attributes or entities that sit inside that one. But when you start going through that process and you uncover what it is, you start breaking down that silos because then you realize that on this form for the quality engineer, it has 4 sections. And in those 4 sections, they actually need to be filled out by a civil engineer, a sustainable engineer, and actually 2 commercial sections inside that there. So then you start breaking that content down. And then other people may be interested in what you're capturing because they're actually doing the same thing, but in a different format. So it's important to go through and actually do the specification and break down the structure to enable that content and that digital enablement and information to be captured. Then with this here is the definitions or the level of the data that needs to be captured. If you're with inside digital engineering, the graphical content or LOD, level of definition, and the level of detail and level of information is quite prevalent. So you've got the details on the side, 100, 200 and stuff like that. But it's important that everyone understands how this actually goes together and where this information drives and how it actually enables us during the construction phase. So if you're talking about a digital twin, by the end of it, we need to be handing over a LOD 300 or is it the LOD 350? So make sure those client requirements are correct and understand how that will go into the client's system to make sure it's connected and they're going to get the benefit out of details. So if you're going to go through to a 500 or any further, like a really detailed model with nuts and bolts is actually really required. So make sure it's very clear about what those requirements are and how it's going to help us during the design, construction, and then also into the operational phase. Then with this one here, you have the PIM. So now what we've talked about people. So people understanding what their processes are, how they're going to engage with the systems, and what they're going to do. We talked about a process. Okay, so we're going to get information in between different systems. People know what they own, and people know what data they need to capture inside that. The information models, so again, about the data, what captured, we've actually mapped out the entities, we've mapped out how that information, and we can be assured of how that quality of data is going to be captured. Then we have the sexy part down the bottom left-hand corner. Now, this is where the digital twin or the digital engineering bit comes into it, the technology that sits around it. But the technology is only as good as the people, the process, and the information that we capture. The technology can't just do this all ourselves. So it's important that we go through these 4 sections of the diagram and make sure we actually delve into each one and map this out accordingly. And once you've done this, you achieve this. So now we've got a fully managed common data environment. We know how data is going to be created. We know what we've got to do during that process. People understand how they're going to generate, how they're going to view their content, how they're going to comment back to it, and how they're going to submit their information as well. We know how it's going to be validated and verified. So during that process, because we know that what stage gates, again, we know that we need to capture this information for the client or this information for the commercial team or this other person. And we understand that there's a governance around it. So we know how it's going to be approved, how we're going to submit it and stuff like that, which then makes it enabled. So we can reduce costs, we can reduce risks if we go back to the start of it. So we've achieved that process. So what does this get you? So part of this is a connected system. So I said to you the common data environment before is an ecosystem of systems that actually are connected. So this is then breaking down those silos. So we need to go through and connect those data sets up. So we have to start thinking with the end in mind. So the end in mind, what we've got to look at here is what do we have to deliver at the end handover in the operational phase. So you'll see in the slide we've got up in the moment, we've got a lot of different processes here, but I want to talk about the end state. So we have to understand what we have to deliver and then how we're going to connect the data source together. So on the bottom, you can see there's different sort of connection or work breakdown structures, there's work packs, there's system breakdown structures. So there's ways of connecting all this information together, and that's what we've got to talk about. So we've got to understand how we're going to connect the information together to make sure it's all coming together in a data repository, which we can then hand over to the end. So start at the end and work our way back. So what this means is we need to then actually have a data dictionary. So this data dictionary here, what we're talking about here is a code library. So we have information from different sources. We understand the different codes that go together with different areas of the project, and we can then map these together. So ultimately, it'd be great if we had one code and one structure that sits across all different areas. But again, we have to be realistic. It's still at this moment in time, we have to go through and make sure we have different areas, have their codes, their flexibilities, but we map them together at a certain level so we can roll them up. And part of this code library then sits within different softwares. So across the top, you have your field view, your data record that captures on site, Prism for your quality, for your commercial capturing, A-side or your document control system, your requirements management system of doors and stuff like, and other processes like Primavera for your work breakdown structure. Again, with this code library, this needs to be clear about what we're doing. So you can't hide this away. People need to know why they've got to do it and how we're going to do it and how it impacts them and why they need to do that process. But once you've got this code library together, then you can actually start communicating and understanding with the different systems and then connecting that data sources together. This then brings us to this one. We can then start demolishing the multiple client and project trackers. So awesome. We have all these different processes. We have all these databases or Excel spreadsheets or project forms and stuff like that. We track information and how we're progressing. It then becomes integrated because now we know we've got a rigid data structure. We know the systems we've mapped out. We know the deliverables we've got, and we've got that code library in there. We can start bringing this data together so we can start seeing about how we're tracking on deliveries, how we're tracking against design, what have we done with commercial, how are we completing our construction phase documentation and preparing our operational manuals. So we can actually start gleaming all that information to single data sources or single dashboards and really tracking the health of our projects and our delivery phase towards the end. So with that there, you've got the construction and handover data. So this process here, so we can actually see that at the end of this whole process, we've connected the data sources up, we have a common structure, and we can actually start using the models, as in the left-hand side there, to see that all this information is being captured. But really, see, that's just a vision, or that's a lens through to the data that sits behind. Now we can actually see that we've got all the information sitting in our dispersed systems that was ready to be handed over as a package that can go to the client side. So they can then take that into operations and maintenance. So here you can see you can actually hand this over. So with Langer Rock, we'll be using eDocs or Springboard systems. We've been going through this process recently. And the team has been really pushing this. We're actually developing this quite heavily. So how we actually go through and hand over our documentations and capture this record so we can give this to the client either as a standalone data source, here's your information, there's all the confirmed records and validated information, or we can plug this into their asset system so that data can be sucked through, so that whole process can be streamlined. Now, with that process, we've got the code library, we've enabled the systems, and we've connected this common data environment. We understand that. So here we were talking about before is here's some data-driven outcomes, so some digitally enabled processes to highlight how this actually impacts the work we do. So one of them is using tools like 3D Repo. This is talking about health and safety in design during the construction phase. So with this as the online tool, you start using markers of place and actually see where the health and safety or safety and design items are throughout the project. But the big thing here is actually connecting through to the data resource of the different project repositories around what they've done. So in the middle of the slide there is actually a data resource they have inside here that actually connects to other projects or a single repository that tells you about what are the solutions that have been used for these different risks. So now you can actually start reusing these processes or these innovations or methodologies from other projects and start bringing that across. So really thinking about that lessons learned portal that we have set up on different projects or through different companies, we can start pulling that information, actually people using that here. It's like, I want to eliminate this risk. I want to reduce the risk, start going through that workflow, and you actually see what's been happening in other projects. You can filter that based off similar sort of projects as well. So you can start leveraging that data really rapidly. And with this here as well, you can connect to other data sources. So here you can pull this information out and connect it to reports and that as well. So you can actually start using this system, but it's actually feeding into the overall plan and the overall dashboard for that project. Then using enabled embedded carbon. So again, using the data that's actually already in the models, volumetric models, but connecting it to actually ISCA databases. So we can actually calculate as the design's progressing, what is the embedded carbon we're actually doing. So bringing this from a outside sort of view, like a ladder thing, bringing this actually into the design phase and then managing this and actually recording this during the construction phase so we can see, are we actually doing what we're saying, or are we slightly improving it, or how it actually works. This one here, you can start then looking at the design during the construction or during the design phase, doing the carbon stuff. So what you're doing here is you can actually start looking at it going, how much steel have we got? How much concrete? If we reduce this, we had this mix, what does this look like? Or how can we make this smarter? Can we remove some of these columns or some of these slabs to actually decrease the amount of carbon, but come up with a more intelligent or a more intricate design that allows us to reduce the amount of carbon we're embedding, but still meet the client's outcomes. So you can actually start using this sort of technology, these connections inside the systems. Then with the same thing with the models, we're indexing them. So we're taking this information I was saying before about connecting the different data sources together. Elements need to be coded correctly to enable them to be identified, which then allows us to track different components throughout the life cycle of the actual design and construction. So is our commercial, sort of quantities going up? So do we need to understand, is there a change because of a client specification that's come through that changes the amount of piles that needs to be required? Have we increased the number of steel due to the fact that there's a different sort of, the design has changed slightly here, but we've actually found a better saving by increasing the steel, reduce the amount of structural concrete, those sort of processes. So we can actually unpick what's changing, what's happening over time, and track what there's meant to be. Again, comes through. So if you think about this, this is data that's interesting, 1, to the estimators, 2, to the commercial team, and 3, also to engineers who have to deliver this work on site. So they understand what they've actually got to actually deliver their works with. Then you've got the digital build methodology. So build it once in the office. So if you think about the whole digital twin for the construction phase, it's always been around delivering certainty and how we're going to do it. So on the right-hand side, you have a picture of the Northern Concourse cantilever slab with the reinforcement all done inside that process, inside that design model. Left-hand side is the real world with the site prep ready to go to actually build that slab. But we've actually been able to build that virtually in the virtual space using the methodology, using that construction digital twin to understand where the concrete pours are, where's the rebar reinforcement going to go, tagging all the different reinforcements, because in that curve there, it's actually every one of those is on an individual, it's actually individual rebar that's there. It's not a consistent approach. So we make sure that we got all the information, got all the rebar in sight. We understand where it is, and we can actually go out and build it and be on time or before time, because we can plan all this out before we even get set on site and stuff like that. So doing that digital build, challenging the way we are going to work in that sort of process. Then we've got the actual more even cooler stuff. So the drones. So how does drone technology start to help? So this one here, this isn't really new, but it's really getting more traction, is around earthworks, quantities, and site tracking. So using drones to see what's actually the stages of the construction site. What's progress this week? What's progress this month? What have we done? But then again, actually this stuff here is around earthworks management, really making this much more accessible to everyone else. So online platforms like Propeller Aero and other processes allow us to actually get there and do these drone flights, calculate on the fly, and then do other quantifications. So like the stockpiles, and measuring that stockpile on your dash, at your seat, on your computer, doing that desktop study. You've got all this technology, all this access to this data right then and there. You can actually see how this works. This then can feed into other platforms as well. So you can actually start looking at machine control and all those sort of processes, connecting that site data back to the engineer or back to the client, or even back to the actual, if you think about stakeholder engagement people and stuff like that, what's it look like outside? How do they actually get this information out? Tell everyone, this is where we're at. What's it look like? Then you actually look at this at the end of the sort of the handover phase. So this one's here is using point cloud data to compare out to the construction. What's the tolerances here and comparing it to the actual design model. Here we're looking like interface management inside rooms. So we're completing, so say for the station example for a construction phase, we have to hand that over to the next contractor to start fitting out their works. How do we straight away say that here's the construction phase, this is what the tolerances are, this is what we've built, and this is the handover of this room. So we can straight away do the scans of the room, use that data here's a record of truth. We have got a 360 image that's been taken with that room, so we can see that as our verification data. And then secondly, using the point cloud data, compare that straight to the model. Have we built this correctly? Is there any non-conformances? And there's the actual proof. We can start doing that as a rapid or as a progressive handover. So having this technology, doing that comparison straight away, using this here and marking this up, is there anything out? Can we close this out faster? So we come back to start with the end in mind now. We're sort of starting to look at that. We've captured the records. We're starting to do the scans and enable our team to see that the information's been completed. And we can hand that information over to the next contractor knowing that it's been completed. Along those same lines is actually the digital scan versus the digital versus reality here. So scanning the actual constructed state and then again comparing it to the actual as-built. So here it's a comms room or a power station, a substation. We've built the actual platform, we've built the structure, and we've scanned the whole structure and compared it back to what is actually there. This forms part of the handover package. You can now give this to the client. This has been as a survey, as a type A survey, and they can actually then use that in an operational phase and hand it over to the next contractor, knowing that's been verified data. So you can see it's the design, here's the actual construction, and this is what you can do on the further. So if you think right back to when I was talking about the asset life cycle, we've built this whole picture up and we can actually hand over this verified data to the end of the project and give that across to the client. The thing that actually, when talking about all this stuff here, it's been great talking to you about the digital engineering, and it's about the actual whole life cycle of the asset and stuff like that. Then how do we underpin it with information and doing those deliverables? We still have to remember there's one key thing that I really haven't touched on, and that's the people in this process. So we have to make sure that we're upskilling our supply chain and upskilling ourselves to make sure we can deliver on these requirements. So with this here, we have to make sure that the supply chain understands what we're doing and why we're doing it and bring them on with that journey. Also, what we need to do internally as well to upskill ourselves, and also working with our clients, because with that digital asset, it's still really important that they set what they need. All this stuff we're talking about and all the methodologies we could do and stuff like that, ultimately it really needs to be driven and needs to help the client manage their systems. So if they're not ready for or prepared, we need to all go on that journey to make sure we're actually doing that so we can achieve these outcomes and these deliverables for the construction industry moving forward in the future. With that, I'd like to say thank you for my time today. Hope you enjoyed it. Hope this was enlightening to you guys about what we're doing at Langer Rourke, but also in the wider picture as well. See you soon.
Thank you, Sean, for your insights. I'd now like to welcome our second speaker, Jonathan Ng. Jonathan has been champion digital transformation and removal of silos in the AEC and infrastructure industry with BIM, BDC and IDD for over a decade. His vision is to transform the way buildings and infrastructure are designed, built and operated using an end-to-end solution. With many years of experience as a project manager and certified as a project manager professional, Jonathan understands the challenges faced by operations and project teams. As a director at APEC AEC for Hexagon, PPM and Geosystems, Jonathan gets to share his vision and best practices from global organisations on how to connect and streamline the business processes across Asia Pacific. Please welcome Jonathan Ng.
Thanks, Amanda. Good afternoon, everyone. Welcome to today's presentation on going beyond BIM to achieve digital twin. I would like to talk a bit on how we at Hexagon believe that this is possible using our various technologies. So, first thing about Hexagon. Hexagon, we are a Swedish organization and we are the global leader in sensors, softwares, and autonomous solutions. Our vision is to empower an autonomous future. Our key areas within Hexagon is number one, reality capture. This is where we make use of our Leica Geosystem sensors to basically capture real-world information. This could be a machine control, this could be a sensor. This allows us to capture information from the physical world so that we are able to digitize this. The second thing in Hexagon is positioning. So we provide solutions from GPS, GNSS. This allows us to capture physical locations of where equipments are, humans are, resources, whatever that we need to capture in the physical world. The third part is location intelligence. So we provide geospatial information so that we can look at things from a city or even from a nation perspective of where things are and connecting all this information. The next part, what we do is design and simulation. So this includes 2D drawings, 3D BIM analysis, so structural analysis, construction simulation, even down to construction management. So construction management, handover, and of course, operation and maintenance. And by ensuring all these information come together, that is how we are able to do autonomous technologies, things like autonomous stuff, where we are able to control vehicles, we are able to control equipment remotely and autonomously. And today, one of the key buzzwords is digital twin. At Hexagon, we call it the smart digital reality. We are able to fuse this through a digital thread that goes from our sensor to our software to ensure all this information is captured in real time. We are able to make use of all the different data, whether it comes from your model, from your schedule, from your budget, and thread everything together so that you have that single source of truth. And that is what we believe is the smart digital reality. So BIM has been around for 10, maybe 15, 20 years now. And across the world, you get to see that there are different mandates. So in certain countries, BIM is mandatory before construction even starts. But most of these regulations tend to involve that it's a submission of BIM before the project starts and then being used as built drawings, right? So everything in between is actually back to 2D drawings on non-BIM workflow. So most people are only using it for the tender submission and as built. And this is one of the problems that we see. The next problem, if we look at the system architecture across contractors or owners or developers, traditionally, these are the four different stages. You have your design stage, your planning stage, your build stage, and then, of course, your operation stage. If we look at it in one more level of detail, you would see that if it's an existing location, you may need to capture the existing conditions. You will do your conceptual drawings, takeoff, estimation, planning, all the way to handover. So that's your typical construction life cycle, whether you're building a building or infrastructure, all the life cycle is pretty similar. Now, from an owner's perspective, they also look at things like capital planning, right? I have a certain budget that I'm allocated. Which project should I do first? Whether there's going to be an impact on cash flow, and of course to benchmark against my previous project in terms of where my costs went and how much it used to cost, what was the time spent, so that you have a good gauge of what you are doing. So that's your typical life cycle. Now, if we look at the solutions that support each of these steps, the first one would be your design solutions. So a pretty common tool that is being used is Autodesk AutoCAD, right? So AutoCAD has been around for many years. People are used to using it in terms of 2D drawings. So some companies that have adopted BIM could be using things like Revit, Tekla, or ArchiCAD. So these are one of the more common solutions in terms of for design for construction. Now, if we move forward to the planning stage, that's where planning tools start to come in. So Again, the more common tools that are being used in this industry is Primavera or Microsoft Project. So those are more common in terms of scheduling, and it does well in planning and scheduling. For companies that have adopted BIM and maybe they are moving towards 4D, again, more common tools would be things like Navisworks or Synchro. So that's what they typically use for the planning stage. Now, as we move into the construction stage, one of the more common tools are document management, right? So companies would use SharePoint or Aconex, where people are sending the documents, submitting these drawings, submitting any information into a shared location. Or if it's not as high-tech as that, what will happen is there'll be a physical server on site, there'll be a folder structure, people are loading files into that server folder structure. So that's your typical tools that are being used. One last tool that is also being used is everybody's favorite Microsoft Excel. Unfortunately, Excel is used everywhere, whether it's from a quantity takeoff to your budgets, to your progress claims. Everybody is using some form of Excels and trying to put data in there. So people are not using all the proper tools, but traditionally we see Excel's files being sent up and down. Everybody is using some form of Excel or Microsoft Office documents. Now, the key issue with that is that scope, time, and cost are not linked together. So you have your design tools, you're using a tool for design for BIM or 2D, and you have your time or schedule in your scheduling software, and you have your costing information, possibly in Excel or some data in your financial ERP. Now, with these silos of data, what typically happens is that as a project manager, I would need to get data from multiple sources and try to link that data together, restructure that data together, and then present this as part of my monthly reports. So this involves a lot of manual work, some rework, and maybe for those that are slightly better in Excel, you're going to start creating macros to link one file to another file, but it becomes so complicated and very difficult to manage. And this is not a one-time exercise. What happens in a construction project, traditionally, you would see things like design changes or schedule changes or cost changes. And then what you're going to get is data in these silos are not updated at the same time. So you may get different results. So if you go to a planner, the planner may say that progress is 77%. Whereas you go to your cost controller, they may give you a different number at 70%. So who is right? Who is wrong? And what is the date of the data? And that is the problem, that most of our data is no longer real time. We are typically looking back in a month's old data or trying to get data from different places which are not updated at the same time. With these problems in mind, that's where Hexagon, what we are trying to do is to bridge this gap. So our latest portfolio, Smart Build Insight and Smart Build Controls, helps to bridge that gap between scope, time, and cost. So we are able to bring in the models from various softwares, whether it's Autodesk, whether it's Trimble, whether it's ArchiCAD. We are able to bring that data in, bring that BIM model in, link it to Primavera or Microsoft Project or whichever scheduling tool with our bidirectional API. At the same time, we can link to the financial ERPs, again with a bidirectional API to bring in actual costs. Together with our sensor solutions, we are able to bring in point cloud data or do digital layout all in that single place. And this helps you to bridge that gap between these three information: scope, time, and cost. So let me just elaborate a bit more on the 5D BIM process. So how we do it at Hexagon, firstly, as I mentioned, we can bring in the 3D models. This can come from various sources, multiple sources. We can aggregate and federate this within Smart Build. And with this data, we are able to extract quantities. So based on our quantities takeoff recipes, we are able to determine what are the quantities within the model. So whether you're calculating the volume of the concrete or the surface area for your formwork, we are able to extract directly from the BIM model and generate the bill of quantities. So now you see a bill of quantities on the left and you see your model together. So this information is linked. You have the exact quantities of each footing, of each slab, or any element within that model. With those quantities, we can start doing estimation. So depending on your level of estimation that you do, we are able to support your estimation with labor, material, equipment, subcontractors, others, that level of details based on the cost database within Smart Build Controls. This allows us to come up with your estimation, and with this estimate, this can then form as your budget that you're going to do for this project. So we can now bring all that information together. As you can see on the left is my bill of quantities with my quantity, with my cost, with some hours, and the 3D model all linked together. The next thing that we can do is our integration with Microsoft Project or Primavera. So we are able to bring in the full work breakdown structure, link it to the 3D model, and do things like 4D or construction sequencing. So with construction sequencing, this allows us to give an overview of the amount of data and whether we are scheduling work correctly. We are also able to do things like production planning, making use of advanced work packaging that allows you to go into more detail and ensuring that each package is a single person is responsible for it. The next thing that we do is to link all this information together in what we call as our smart mapping or 5D mapping. This is a rule-based method rather than a singular drag and drop. So if there is a logic, we are able to set up this rule, and this mapping process can actually be automated. For those that is manual, you can still make these manual mapping, but the bulk of the mapping should be able to be done automatically. And with this information, now you can see that you have your scope, time, and cost all linked together in one single platform. As construction begins, we are going to be able to report progress, multiple ways of doing it. You can continue to use your scheduling tools to report the progress and it be imported, or you can record the progress directly in Smart Build, which allows us to capture the actual information. At the same time, we're able to get the actual costs from your financial systems, again, whether it's the Oracles or SAPs, that we are able to bring in the actual costs. And what we are doing here is earned value management. With earned value management, we are able to do things like calculate the CPI, the Cost Performance Index, or the SPI, the Schedule Performance Index. So this gives us a good idea of where we are in terms of the project. But not just that, we are also able to do things like forecasting. So based on our current trends, based on our current CPI, we are able to forecast where will you be at completion. So estimation at completion. So we are able to apply different rules, your own formulas or standard formulas within the system to provide that forecasting capability so that you know where your project will be. And we don't just stop there. We take it the next level is this, as you can see here, is our cost visualization. So we make use of that CPI index. We bring it back to the BIM model, and now you see a color-coded model. So what you can see here on the third floor, you can see the slab are all red. This means there's a cost variance here, and it's greater than 20%, and that is where you can then drill down in terms of where the problems are. So in weekly meetings or in your monthly project meetings, the system provides you the information in terms of where the cost overruns are. We do the same thing as well for schedule visualization so that you can see where the delays are, whether it's in Tower 1, whether it's the columns, the footings, all the information is linked, and therefore we can present this automatically to you. So the next thing that we do is our integration with our sensors. My colleague Greg will speak a bit more into that, but one of the key areas here is really integrating the information that we have all these point cloud information so that we can then overlay it against the model and then see what the potential issues are or what the issues are. So in this next one, you see here the point cloud, which is that millions of points that we've captured with our sensors, and then is represented in these dots. It's overlaid against the model. In this instance, the step is not positioned correctly, so there is a slight variance, whether it's within your tolerance or if not within your tolerance, then an RFI or an issue or a defect can be created directly in Smart Build, and this RFI can then be sent to the contractor or the subcontractor or whoever that needs to rectify this problem. So trying to manage all the information in that single source of truth rather than having a piece of paper or going to another system to create that issue list. So in this way, all the information is stored so that you can continue in passing this information across to the owners. As you can see here, this is just a sample of the issue where you can select your discipline, whether it's architectural, whether it is structural, whether it's mechanical. You're able to collaborate on these issues, assign it to the correct people, and the person that receives these issues will have all the information. We'll have the model, we have all the work model elements, the work packages, or any other issues that relates to this. He will get a whole package to understand what exactly is that issue. So just to summarize, one of the key things is that this is one way that we believe that you can take BIM the next step further. So instead of just using your 3D designs just for clash detection, as-built drawings, or just submission, what we believe is BIM can be used for your construction stage in terms of things like 4D, 5D, and of course, integration with the sensors to do things like the layout process, to do reality capture, so to do your QA quality checks as well. So this is one of the key differences that at Hexagon that we can differentiate ourselves. So again, what I've shown today is mainly the Smart Build Insight and Smart Build Controls, but within the Hexagon AEC portfolio, we actually have a bigger solution. We have various solutions that even support things like material management, completions and commissioning, and machine control. So in terms of capturing information or even calculating your cut and fill, all these are possible with our various solutions across Hexagon for the building and infrastructure market. And of course, from the owner's perspective, we're able to do things like all the capital planning that I mentioned in one single system. So in this way, we have an end-to-end life cycle that can be supported, right? And still integrating with other systems from whether it's a financial ERPs or other information that you need to bring in. As a summary, what Smart Build is a cloud platform. So this allows you to be able to access the information anytime, anywhere with real-time information. You are able to do things like model comparisons or schedule comparisons. This allows you to ensure that all your information is up to date and a proper project management information system. In terms of cost control, we cover the whole range from estimation, budget, change management, all the way to your own reports, which can be configured by yourself. With that, I'd like to thank everybody for attending today's webinar.
Thank you, Jonathan, for your insights. I'd now like to welcome our third speaker for today, Franz. Greg has over 25 years' experience in the engineering, 3D and laser scanning sector and has invaluable insights into the exciting ways in which technology is evolving and revolutionising the way we capture reality, and has degrees in building design and surveying. Today he heads the reality capture segment at Leica Geosystems, part of Hexagon, and their range of reality capture devices such as the BLK range, RT360 and P-Series, along with software such as Cyclone, CloudWorks and TrueView to maximise the use of your 3D data. Please welcome Franz.
Thanks, Amanda, and thank you to Engineers Australia for inviting me to speak. We just heard Jonathan provide an overview of Hexagon and how our Smart Build portfolio can let you create a digital twin and maintain a digital twin. I will now delve deeper into our sensor technology and how that can be used to create a digital twin. So we have a broad range of sensors that can be used in a number of different ways. What you see here is our Pegasus mobile mapping system, which combines a number of different technologies. You simply just drive around, and it's great for capturing campuses, large precincts, and obviously transport infrastructure. The common thread amongst these sensors, which I'm about to show you, is that they all, except for one, capture images and point cloud. So we can see Paula here. She's using our handheld device called the BLK2Go. You simply walk around, whatever's in its field of view, it will capture. And like I said, it's continually capturing images as well as scan data. So it's a handheld device. You have an app so you can see the areas that you have captured and haven't captured. And it's great for capturing data really, really quickly. Next product is BLK3D. Very simple device. It's a photogrammetric device. You simply take snapshots out in the field. They get synced to something like BIM 360, where people back in the office can start to take measurements and do markups. Really useful tool to collaborate what's happening on site quite easily. The RTC 360, which is still basically one of the fastest scanners on the market, it has some unique technology called VIS, Visual Inertial System. It's continually tracking you as you move around site, which makes it much easier to use for people who don't scan on an everyday basis. The BLK 360, it really did revolutionize reality capture when it was released in 2017. It's very easy to deploy, quite small, sticks to the BLK ethos of one button operation. The images that you get out of there are fantastic. And our P-series scanners, ideal for where you need to measure up to a longer range, maybe up to 1 kilometre. It's our survey grade instrument. And where you need that extra oomph, that's where you would use a P-series scanner. Of course, we have some Office desktop software which lets you combine all those different pieces of information. Register 360, which we're looking at here. It's a very visual software which makes it easier for users, new users, to understand what's going on. And the whole reason you would use Register 360 is just to check that everything has come together and it's in the right space. And then you would create something like this, which is a typical deliverable. This is a colorized 3D point cloud, which gives you a complete overview of the project. And now more than ever in this day and age, collaboration is key, and being able to speak to your colleagues and how that data can be used is really important. CloudWorks plugins lets you use that same data in third-party software such as AutoCAD or MicroStation or BricsCAD. So collaborating makes it much easier. Then many of you may have seen our recent announcements, which is our autonomy range. So the BLK Arc is a sensor which has been designed to go on robots. And the first instance of this is with Boston Dynamics Spot. So we really see this as a way to capture data autonomously. So it could be for doing regular audits on a site, but obviously being able to deploy it in dangerous or hazardous situations is another key area where we're using BLK Arc. And this is the result you get from the BLK Arc. It's a colorized point cloud, so you can use that to understand what's happening on site. As I said, you get images there as well. To create the path that Spot follows is quite simple. Here in Cyclone 3DR, you create that path. You just simply define where you want it to go, and then that gets uploaded to Spot. You could be back in the office to upload that path and then send Spot on its merry way. And you can see here that the avoidance systems are working really well. So they're avoiding the prop. So Spot's avoiding the prop, and then at the same time, it then goes back to the path that has been designed or designated for it to follow. One of the really interesting things about BLK Arc is that you can use it in that continuous mobile mode, and this is typical data that you get from the Arc, and you can also use it in a static mode, so it effectively replicates a traditional scanner on a tripod. So having those two modes can be quite useful for capturing data, and this is basically what it's all about, comparing that captured as existing conditions to a 3D model. It has happened in the past where something like a rectangular column has been placed in the right position, but it's been orientated the wrong way, and that's the sort of thing that doing this type of analysis can pick up early. And then finally, the BLK to Fly, which really is the first of its type. It's a scanner which has been designed from the ground up pardon the pun, to fly, whereas most other solutions, it's a UAV platform with some sort of scanner bolted onto it, whereas this has been designed right from the start to be a flying scanner. To create the flight path is very straightforward. It has some fantastic autonomous technology, so that's using a fusion of both LiDAR and radar for its obstacle avoidance. So obviously, once you've created that flight path, you want to make sure it's not going to bump into anything. So basically, once that flight path has been created, you push the button and off it goes, start scanning. And obviously, being able to get access from the air means you can capture information that you can't capture from the ground. So typically, rooftops is a classic example of where you would need that extra information. So being able to combine both BLK to fly data with something like our BLK to go, or even an RTC 360, combining those different data sets into one, you can then create obviously an exterior representation of your building, but using the handheld devices or a terrestrial device, you can also go inside the building as well. So where to start? Obviously, the first place to start is using one of those sensors to start capturing data, and you would do that either on an existing brownfield site or a new build, or you can use that in a few different ways. So here we have an RTC 360 in a typical application. It's a plant room, really easy to use. You just set the scanner where you need it to go, push the button, and it'll start to capture data. We have some very user-friendly field software, so it's just tablet-based, or it could even be on a phone. You use that just to check that the scans are coming in correctly, but more importantly, you can do what we call add tags, and tagging in the field, I think, is more and more people want to be able to do. What you see here is my home office. I've actually changed the setup of that. Where that red shelf is actually the shelving behind me now. So what I've got here is our BLK 360 on a tripod, and I'm using that to scan my house, and then I'm controlling that with a little BLK 3D photogrammetric device. So that's what you see in the center of the screen. So what I'm about to do now is capture a tag with the BLK 3D. So I'm taking a photo of a crack in my house. Now, my house is a really good test bed for this sort of thing. So this is crack number 1. I can give it a label. I can call that crack number 1 or whatever it is. And then once I've done that, I then locate in that scan using the panoramic image where that tag is located. So I define where it goes. And then from this point on, that tag is embedded in the project, and then people downstream can open up that same tag and use that for all sorts of different purposes. So now I've moved on to my second thing that I want to tag. Interestingly enough, I did this original video some time ago, and some of you may know that I'm based in Melbourne, and we recently had an earthquake, so I plan to go back and take some images of those cracks to sort of see whether they've progressed. So that's quite a little interesting side note. So a tag can be an image. It could be an image used from the tablet or phone that you're using, or it could be from another device. It can be a voice note, like a little audio voice note. It can be a movie. It can be a digital file. It could be a PDF, anything like that. This is one of the other great things about using tags. To capture that power board in my house, just using the scanner alone, I'd have to move the scanner directly in front of the power board to be able to have a good image of that. Whereas if I capture a tag, that is a really smart way of being able to add more information easily. So now I've opened up TrueView, our free desktop software, and this is the project. I've got a number of scans, and you can see those little grey icons. They're the tags that I've captured, and all those labels that I've created, they're there. So I can view anybody who opens up this same project. You can use a web browser in any location, or you can use a desktop app to open up that file, and then everybody can start looking at that same single source of truth, as they say. Because those tags are BLK 3D images, I can actually take measurements directly on those images. That same project, I could then use CloudWorks to open up in something like AutoCAD or MicroStation. Here we're in AutoCAD, so Point Cloud gives me the 3D representation of my project, and then I can use TrueSpace inside AutoCAD to open up the panoramic images and look at those tags as well. So I'm not going out to some other software. This is all happening within that third-party software you're using. So like I said, it could be BricsCAD, or it could be MicroStation, it could be Revit, Navisworks, etc. And here again, you can see how I've opened up one of those tags, and then I'm actually taking a measurement on the picture, because sometimes it's actually easier to take a measurement on the actual image than in the point cloud or the mesh. Previously, we heard Jonathan talk about our smart build solutions. So this is one of them. This is a product called SDX. And we use, SDX uses those true views. You can see we've got some blue vessels there. So using that, combining true views with SDX, it's a really smart way to keep track of your assets. SDX lets you bring in disparate pieces of data and information. It could be simple 2D drawings, or other PDFs, etc. And you can use that to keep track of your facility. And having that access to those panoramic images is obviously a great way, rather than just looking at a simple 2D drawing of a facility. As they say, a picture tells 1,000 words. So we'll use this example here with the plant where the blue vessels are. So I've just jumped back into True Views. True Views is a really simple way, especially for people that haven't been to site, for them to understand what the site is. So you can simply click on those little red dots, and that moves you to different locations to see the panoramic images. What you can also do is create these snapshots. So somebody else has previously looked at this project, and they've created these snapshots, these points in time, and they've created their own markups. They've added measurements and notation and things like that, which is a great way to communicate to other people information. So it's a succinct way to quickly go through the project using those markups. We can view the point cloud. We can import a 3D model into this free TrueView viewer. So now we're looking at the 3D model of that project. You can turn the panoramic images back on, so you can see the panoramic images with the 3D model, which is a great way to understand how a new design might be affecting the existing conditions. And then we can also turn all of those off and just be looking at the point cloud itself. So what we're looking at here is the actual scan data. It's the point cloud. It's just colorized. And like I said, it's really easy to understand what you're looking at. Keep this tank and these pipes in the back of your brain for a second, because we'll come back to that in a minute. So that's True Views. So typically over the past 10 years, the way people would be using reality capture data is something like this. You'd be using the point cloud, and you'd be doing something like a scan to BIM type of process, where you bring the point cloud into some software. Here we're using Revit. The point cloud's been introduced into Revit. But using point clouds is actually, there's some advantages to using point clouds, which I'll talk about later. But the great thing about CloudWorks plugins, like I said, is you could be opening this same project in Revit or MicroStation, and everyone's looking at the same data. So CloudWorks has some great tools for that scan to BIM process. It has fitting tools, so you can use a specification table to fit steel columns and beams. You can fit windows and doors and things like that, pipes, ducting, all those sorts of things. We have fitting tools that make it easier to go from a point cloud to a 3D model. And there's no doubt there's instances where you need to create a 3D model. What we're now starting to see is a hybrid approach. Not everything needs to be converted from a point cloud to a 3D model. So now we're starting to see some really smart ways of using the point cloud. And one of those is Point Fuse, powered by Jetstream. So Point Fuse has some unique, clever features about it. So you can import an E57 file into Point Fuse, but we also have some workflows and wizards where, if you're using our sensors, such as an RTC360 or a BLK2Go, etc., it's got some wizards in here to quickly create a mesh. It could either be a low resolution mesh or a really high resolution mesh. And then this is one of its secret special sources. It has categories that are using IFC standards. So it'll create a mesh of your project, which will be colorized, but it also segments the mesh. And what that segmentation does means that it allows you to categorize those different elements into the appropriate category. So that tank, that vessel, can be put into the tank using IFC standards. These pipes, which you've just selected, they go into the pipe category, and because they're using IFC standards, they can be read in other software. And of course, the other great thing is, well, not of course, but the other good thing is you can assign an asset ID to those specific elements or some sort of unique identifier. So it's not just a dumb mesh, it's a smart mesh. So that is the colorized mesh, and because it's colorized mesh, it's very easy for people to understand what they're looking at. So from this smart mesh, which has been categorized, you can then do something like upload that directly to BIM 360 from Point Fuse. So now we're just selecting which categories. It could just be the structured elements, or it could just be the pipe runs. You don't have to upload everything. And now that's opened up in BIM 360. Like I said, because we're looking at a colorized textured mesh, it's much easier for people to understand what they're looking at. So this is one of the key aspects. You don't have to convert the point cloud to a proper 3D model. You can create this smart mesh, and it's a really quick way to create a digital twin. So now in BIM 360, we can start to do some collaborating. We can start to do some asset management. So we're going to create an issue here. Mike from Point Fuse has done a great job with these videos. So now he's just going to zoom into this tank, and he's actually going to say, okay, we need to create an issue. Somebody needs to clean this tank. So he's now saying, okay, well, we need to clean this tank, and then he's going to assign that to the appropriate person to request that happens at whatever point in time that needs to happen. So from, like I said, this is a really quick way to create a digital twin. And it's I guess you could call it more of a hybrid approach. Of course, we can go into Navisworks as well. So that's that same project opened up in Navisworks. We can go back to this tank that we were looking at in Point Fuse. So when we actually select that tank, because it's been categorized in Point Fuse, you can see on the left-hand side that all those valves have been categorized, and you can actually see what the asset ID is for that, because it's been categorized in Point Fuse. So that's the great thing about it. Here we have two vessels. Obviously, the one's the 3D model and one's the actual. This is quite a gross mistake, and obviously it's just to show a particular workflow, but we can do some simple measurements in Navisworks, so that's obviously quite easy to do. So that's quite useful. But what we know Navisworks for is doing things like clash detection. So now if there's a new pipe run that needs to be installed, we can do some sort of clash detection, compare the new design to the existing conditions. And because it's a smart mesh, it will come up with a clash. The red is the existing conditions, the green is the new 3D model. It will say it's clashed with that particular pipe ID, whereas if it's not categorized, it's just a dumb mesh. Navisworks would just say, well, I found this clash to the mesh. It can try and it will be able to zoom in, but being able to have that smart extra information in that mesh makes it really, really useful. So some final comments. Capturing tags in the field, both on a brownfield site or a new site, is really, really useful because it can just add so much more information, especially downstream. Point clouds and meshes. I believe you need to use both. There, meshes are fantastic for providing context, which is great, but point clouds are fantastic for that scan to BIM process. So if you need to fit steel elements using specification tables or ducting and things like that, you're much better off using a point cloud rather than a mesh. And like I said, not everything needs to be converted to a 3D model. Obviously, if it's a brownfield site and there's some sort of extension being done, definitely create a very accurate model of that interfacing area. But why convert the rest of the building when you can just use one of those smart meshes? So thank you very much for attending. I'm really looking forward to answering some of the questions that you guys have posted. And now it's back to Amanda. Thanks, Amanda.
Thank you. A big thank you this afternoon to our three speakers, Sean, Jonathan and Greg. And it's now your turn to get involved. So please, our speakers are here and ready to take your questions. If you'd like to submit a question, could you do so via the chat box? If you'd like to provide your name, you don't have to, but certainly who the question is for. And thank you to everyone who sent through some questions at the time of registering for this webinar. I might start off from a question direct to you, Sean, that's come from David in New South Wales. Good afternoon to you. And then Greg, maybe you can also comment on this one. But Sean, David is asking, how useful is BIM if the people on site are not fully qualified to implement? And you touched on this in your presentation too. Thank you.
Thanks, Amanda. Yeah, to respond to this one is I think it's around the training of the people and stuff like that as well. So that was that last slide. So I was speaking about it's one of those processes where it's great that we're talking about how we do all these digital processes and we use the models. If we're not actually making sure that we're actually upskilling our supply chain and our teams and stuff like that, we'll never actually realize that benefit. So one of the things you got to do is, and especially this is why we go to work here, is we define what the digital strategy is for our projects. We identify some of the innovations that we want to do. And then we actually also focus with our supply chain what they can do and break down what is actually required in terms of like information capturing and stuff like that as well. So do you need to supply that digital model back, or are you just literally capturing information? And how do they actually put that into our systems? So a good example of that is we're using Springboard and eDocs to do that now. So we're capturing field records in FieldView, which then gets populated. We extract that into our eDocs and Springboard platform, and then we can actually populate that into our O&M. So it's the understanding of how that works. These are the information you have to capture, and then you go through. That helps them with their work, right? So that whole process. So it's very important. So that it's working with the people to understand it, and if they don't understand it, stuff that's coming along with the journey, because it's not. This is the thing with the construction industry at the moment. We need to make sure we're always looking for change and innovation. And then if we're not doing that there, we're not going to be able to keep on moving forward in this way. So it is really important that we all come together on this journey. So it's not good that I have that data and my information. I hold it close to my chest. There's no point. So I think that's the benefit, and that's how we're going to upskill our people to make sure we meet these requirements and go forward together in the future.
Thanks,
I'll add to that. I think it's
thank you.
Sorry, Amanda. It's what we're seeing as well is it's just like Sean mentioned is just go with it. We've seen a number of companies. There's a good example here in Melbourne where we've got an MEP customer where they're using our scanners to scan, but then they're creating their own digital content, which they're then providing a booth on site, which has VR headsets, and then any tradespeople can go into the booth and check out what they're about to install in the 3D model. So initially there wasn't many people using it, but it didn't take very long for people to start to adapt and to start to all of a sudden go, well, hang on, I'm trying to do this. Could I use this technology to do this? Which is what actually happens often with technology. It's used initially for one particular purpose, but doesn't take long for people to realize that it can actually be used in a number of different ways.
Thank you. Our next question is a great one, talking about existing or aging buildings. And we might start off with you, Sean. The question is, applying in BIM in new projects are great. How about revitalising or recommissioning existing or aging buildings? And if you would just answer that one, Sean, but maybe Jonathan, you can come in and talk about the digitalisation aspect. And that question's coming from Tak Chow, who's in Asia. Thanks, Sean.
No worries. I guess this one is very similar to the process of I'll talk about when I was working for Transport for London. So it's realistically one thing there is actually understanding from the client point of view of what your systems are, I guess, in that sort of sense there, and how you're actually going to be applying that to your asset. So from a construction point of view is great. We can suggest and help those with the clients as well. So that's actually what we're sort of some of the value adds or the information that we want to capture during our construction phase to help that when we hand that over, it's going to be much more beneficial to you to use that. That's the sense there. So it's going down that journey. And this actually sort of ties into one of the questions in the chat as well, is around where do I get data sources from, or sort of systems implementation or that information capturing. So it's really then looking at what your records are, what the systems you've got in place, then going through the records or information of entities and what's your attributes, or that's the stuff that you need to capture. So really focusing on that sort of client side first, and that then lets us sort of drive the construction phase and the records we're going to be capturing during that phase, and that actual digital process or the digital twin handover at the end to recommission that. And so there's some really good examples about how clients or they're using that sort of that grading of the information as well, right? So from you look at utilities, you got level D to level A, and you got people like Heathrow and stuff there, like Heathrow Airport in the UK, that do that sort of stuff as well. They know their digital asset. Any older one, they're upgrading as it goes along. So and it means that they know what's out there, so they don't have that sort of utility strike where I think this is where that sort of came from. The flight tower got knocked out, so that was a few years ago now. But that was exactly what it was. They didn't know that cable was in the ground. So if you think about Heathrow being knocked down, there's a whole problem with that. So those sort of processes need to be applied.
Thanks, Sean. And Jonathan, do you want to just expand on that from a digitalisation perspective?
Yeah, sure. I think one of the key things is today we discussed that we're using scanners to basically capture as-built information. And this tends to look as though that we are only using scanners after construction is completed. What we have seen is also using this scanner information to capture existing conditions and have that BIM model if these BIM models are not ready. So a lot of existing projects or older projects where BIM models were not used, we are also using scanners to convert these point clouds to BIM models and continuing with that process. And I believe that there's a lot of data, right? So a lot of data is brought into solutions like Smart Build to help you to actually benchmark and compare against what has been done before. So this is how we see that scanners can actually be used at initial stages and not just for as-built drawings.
Thanks, Jonathan. And back to you, Sean. We've had a great question that's come in from Sebastian and Victoria, and we also had a live question that came in from David. So Sebastian's question is, how can you make digital twin even better? And maybe you could also tie in David's question, which is around construction and later facility management, and citing the NatSpec guide. Thanks, Sean.
No worries. I guess for this one here is what the reason why I want to tie these two together is sort of it's sort of very easy for the DE, like with technical people like myself, to delve into a lot of level of details and information about an acronym. So we could have a full conversation around with it without really speaking a word. So with this digital twin and making it better and stuff, that is actually breaking down that sort of silos of information and the methodology of how we talk about stuff, and actually making sure that all the information and the processes we're talking about is accessible by everyone. So again, tying it back into people that aren't upskilled in this process as well, making it digestible. So yes, the NatSpec has got a definition about what all the information is we have to capture during that phase. Going through that, and you could look at like PAS 1102 and other industry standards that are out there from other countries, and definitions about that sort of process there. But it's also making sure that we're actually talking about the whole ecosystem of a project lifecycle. So we're not just talking about we're talking about the pre-feasibility stages and stuff like that. We're talking about the scanning of the data, the existing infrastructure and stuff like that. All those sort of processes, we can tie that into the digital twin. So and sort of tying back to what I was sort of presented before is like that asset lifecycle. So a big thing that we do consistently is always when we start a new asset, like we not start a new asset, when we go to do existing work, or we do that open heart surgery, like on an asset, so say like Central Station, first thing we normally do is we go out and validate survey. We go out and scan and redo stuff. It's a very costly. It's like that's just it's a information waste. So part of this process, we break it down and we actually get these processes in place. We make this accessible with digital twin, and we know the data is validated. We can actually then reuse that data multiple times, and we can actually reduce that sort of data waste and stuff like that. So if we can actually get everyone accessible to it and everyone understands those processes, that will increase the digital twin adoption, or the methodology about how we use it, and also make sure that everyone's in that conversation, so we're not just working in our own separate silos. I think that's a really key thing.
Thanks, Sean. And now moving on to, we've had a question coming from South Australia, from Hilton. We might start with you, Sean, and then Greg, you might want to jump in. And the question is, how is digitisation resulting in less projects costs and time taken? Sean.
Yep, for sure. So actually, I'm going to actually shout out to there's two people on the project we've been working on at Central Station have done a great job with this. So one of the things there is we've been using like what's called a digital build process, and we're using 3D rebar to actually do that. So that was actually that Northern Concourse slab we were talking about there. So we've been actually able to get there and really digitize the methodology of reviewing the reinforcement. Like I know this actually technically this isn't new, right? So but it's really embedding that process. So it's working with a team, working with the supply chain, really breaking down the methodology, the construction sequencing, and then getting there to that point where you're like, right, this is where the rebar's going, this is how we're going to do it, and that's the process. So with that process, we're actually saving quite a lot of money. So that's actually, we've increased time and saved costs about rework. So that's the main thing we're trying to achieve here. The other thing then too is you start looking at other projects we've done around actually tracking the deliverables of during the design phase, and also operations, so the actual handover documentation. So we've got those tracking, so we can actually now get there and see how we're actually moving along our project based off with the commercial claims. So we can actually go, right, we're paying people on the time, they're delivering on what they need to do and stuff like that. But also then that's actually feeding through to the client straight away. They can see these deliverables coming in and they can already start testing or start inputting that information straight away. So we can actually start handing those over. So these are actually where the cost and start reducing the cost of those projects, because when you get to the end of it, it's where we all sort of, the traditional approach is we've got to sort of put data together and get it a handover. But that's the methodology now. So that's actually how we're reducing costs. So that's making the life cycle of the project shorter. We're taking more time up front to make sure that we're going to deliver it on time at the end. And we're actually seeing those benefits on site in the construction phase.
Thanks, Sean. Greg, do you want to add to that?
Sure. I gave the example in my presentation about talking about, checking things like the orientation of columns. They're things that have happened in the past where, doing checks and balances digitally along the way really help. But like Sean alluded to, it's not just during the construction phase, it's during the life cycle of the building, which a digital twin will help. Having all this extra information, it's still amazing. You can buy a $50 item online and it comes with an instruction book, but so many buildings and residential houses, etc., have no manual for the building itself. So when it comes time to either extend or repurpose that building in some way, having all that extra information is so beneficial.
Right. Thanks, Greg. Jonathan, we've just been talking about costs. I've got a question here that you mentioned Hexagon offers an end-to-end solution for the construction life cycle. Does that also include a project management system for tracking costs, contracts, and even portfolios? Jonathan?
Sure. Yes, so our Smart Build portfolio covers the whole life cycle. So this includes the cost management, as I mentioned, where we can do things from estimation, budgeting, and all the way down to cost control. But the key thing is this is all integrated. This is integrated with the BIM model. This allows you to achieve things like 5D, where you can do these simulations. And this also ties in with things like changes, right? So what happens when a model changes, a slab is added or a column is added? What is the time impact? What's the cost impact? So these are things that we are able to do in Smart Build to calculate and also provide this information of what is the impact. So how we manage these changes, how the model has changed or how the schedule has changed, and what these impacts are. So yes, we are able to cover this whole project management system with scope, time, and cost.
Thanks, Jonathan. And Greg, we have a question that's coming in asking, is it possible for companies to perform their own data capture on site using something like a 3D scanner? Thanks, Greg.
That's a good question, and it's getting asked more and more. Short answer is yes, but the caveat, and there's a few other questions in the chat that have come through relating to this. The caveat is if it's a small project, then no problems to do it yourself. It could be a small plant room or something like that. But if it's a larger facility, a larger complex like a train station or a factory or something like that, then you really should be having a professional surveyor provide a framework which is laid down right at the start, and that'll enable you to scan yourself, because then the scans that you are performing can be tied into that framework. So it's a really good question, but like I said, the short answer is yes, but there is a caveat. You need a framework set up by your professional surveyor first.
Thanks for that, Greg. And Sean, we've had a question coming from David, who's in Queensland. Good afternoon, asking, are there any cases where BIM and digital twin technology is affordable in the context of the total operating costs and benefits? Thanks, David.
I actually got a colleague. Actually, he could answer this actually quite good, because he was a part of the BAC team up there in Queensland actually. So in sort of that's the stuff there. So he's got some really good records around the implementation of digital twins for the BAC or the airport up there, and the costs that actually they were saving. So understanding what they're building in terms of that, so what they're going out to build, and then putting in the definitions around what data we have to capture as contractors and what formats we have to hand back. So what they're looking at, so they're connecting to their systems. Additionally, also they're talking about sensors and stuff like that as well, and putting in that information around so they can analyze how their operational, their equipment's operating. So take, for example, an aircon unit if it's actually breaking down, is it a fan that's breaking down, stuff like that. So looking at that sort of technology. So now, if you're talking about affordability and stuff like that, that's where it becomes affordable, because they've got a clear set of requirements, they understand what that is, and they can start realizing those benefits of what they're actually putting in place and how it's working. And I guess that ties into one of the other questions we had during the session too, around the business plans and stuff like that. We can actually, that's a process we've got to put together. So if the client isn't fully aware of what they're after and stuff like that, it's really working with the clients and stuff like that, understanding what their digital requirements are, and then making sure that what it is not like a gimmick in terms of that we're trying to produce and stuff like that. This is not we're trying to realize the benefit of what we're actually doing. So part of that process is really going on that journey together, identifying where the benefits are, like what we're going to achieve by doing that, what's the project scope, and building into sort of like the stuff that Greg's been talking about and Jonathan, like all the different systems and approaches. So can you actually apply an umbrella of data across all the different systems that they've got internally? And then also too, all the data and scanning and the products and stuff. That's like, where's the benefit? Where's that going to come into it? And is there actually a plan that you can actually do with the clients to stuff that? And that's where that sort of business case comes into it, and they can then work through their digital process. So that's sort of the summary there. So there's some really good examples out there where like the AC and other clients are actually starting to see that benefit come back in the operating phases. And then they've got that reusable asset data at the end of it, so they can keep doing that asset maintenance and that sort of minor, the next phase. So they're not doing a major upgrade, they're doing minor updates and projects. They can keep reusing and updating that data because they've got that structure set up.
Thanks, Sean. Jonathan, an interesting question we have has come in saying, I heard Brixis is now part of Hexagon. Can you please explain what this means and how it relates to Smart Build?
Sure. So Hexagon acquired Brixis a couple of years back, and one of the key solutions that they offer is BricsCAD, which is an AutoCAD replacement. This basically works on the same DWG file format, but then one of the key functionality with BricsCAD is that you're able to do BIM directly in the same solution. So we are able to do 2D drawings, we are able to do 3D and BIM all in one single platform rather than multiple solutions. And all of this is, of course, integrated into Smart Build, where we have a BricsCAD plugin that allows that seamless flow. So that flow of information from BricsCAD, that 3D model can be passed to Smart Build and to do the construction management as I described earlier. So I think the whole solution of what Hexagon is trying to do is really cradle to grave, from design, construction management, handover, and even down to asset management. So that is what we envision for this segment, that Hexagon can provide a solution from end to end.
Thank you, Jonathan. And Greg, we've had a question come in asking, what's the accuracy for the measurement of scanning? And that came in from Rongan. Thank you.
Yeah, it's often asked as well. It varies. It depends on what system you're using. If it's the traditional tripod-based system, they're accurate to millimeters. If it's a mobile system like the ones that are on mounted to cars, they could be 15 to 20 millimeters. But then you have the other issue, which I alluded to before, about if you were to scan a whole factory precinct, that's where you need a really accurate framework to be able to maintain those accuracies throughout the site. So it's a good question. It varies, and it can be answered by, you have to use the right tool for the right job.
And just staying with you, Greg, and we're getting down into the specifics, Indra has sent through a great question. Good afternoon. Asking Greg, can you explain the minimum hardware, CPU, RAM, GPU for Leica software? Thank you.
Generally it's not a lot, but the bigger question is, like for smaller projects, you actually don't really need a lot of computing hardware. It could be something as simple as 8 gigabytes of RAM and a small 1 gigabyte graphics card. But if you're working on larger projects, then you're not going to be using the minimum specs. You're going to be using something as best as you can. So it's a situation where you don't really want to use the minimum specs. You want to really go as best you can.
Thanks, Greg. And we are rapidly running out of time, as always. But I want to pose a question to you, Sean, about the different BIM platforms. And we're being asked is, how do the different BIM platforms talk to each other? By importing, exporting models, we will lose data when transferring between platforms. When is this needed, Sean?
Yeah, it's a common thing, this one. So yes. So I guess the best way to answer this one is it actually comes down to so the best way to answer it is we need to start following, like, as an industry, you have to constantly try to follow the industry standards. So we have an IFC format, for example, right? So we need to start really sort of leveraging what that process is to ensure that we're not going to have that data loss. Because there's examples where we've gotten one model come from one platform to the next one, and then it wipes the data off it just due to the fact that it's the way the vendors are operating in that sort of sense. So it is down to what we write in our digital execution plans and the way we want to exchange data and how we work with each other. Because obviously, as well as mapping to some of these industry platforms is also a little bit of a challenge. But if we have the rule set up and we put the time frame in this time up front, we can then start doing that. So we've had some good results with this down with some of our projects in Melbourne. One of our team members there has done a great job around that. Actually writing up different performers around exactly that. So this platform exports out to the IFC in this format and this way. And that means then we've got a consistent methodology of exchanging our data and making sure we've got a single source, and that's the stuff there. But realistically here, we're still, I guess, in a way, as an industry, still really got to get there and have that defined and really work with that one and work with our vendors, I guess, with the software vendors as well, as making sure that they actually are going to open up platforms for us. Because yeah, it's sort of one of those things we get hamstrung a little bit with. We want to do this exchange, we want to send data between each other. We really want to get to this point where we've got this data-rich environment and we're doing this digital twin, this process of getting that. But we have to really get there and define and really push that with them as well and make sure that's the case there.
Thanks, Sean. And our final question, and I want to put this one through to Jonathan, that's coming from Tim, asking what tools are available for change management?
Yeah, sure. So again, with Smart Build, one of the key things is that we are able to bring in that model, and we don't just bring in the model, we compare the model against previous versions. So Smart Build is able to check what has been added, what has been modified, or what has been deleted. The same that we do with our schedule, that if a Primavera schedule has been updated, we are able to identify automatically what has been added, modified, and deleted. And by allowing this, we are able to actually see all the construction management, the time impact, the cost impact, because we are able to identify this for you. So instead of going through thousands of activities, these can be automated. And again, with all these rule-based engines that we're using, all these mapping, all these are always synchronized, and that information flow can continue through the whole construction period.
Thanks, Jonathan. And that is all we have time for this afternoon. But please join me once again in thanking Sean Webster, Jonathan Eng, and Greg Franz for their time and insights shared today. I'd also like to thank Engineers Australia's industry partner, Hexagon, for making our webinar possible. As always, we're looking for your feedback to help us improve and plan future sessions. So if you could take a couple of minutes to complete a short feedback form, which is linked in the description box below. Thank you again for joining us at today's Thought Leaders session, and we hope to see you at our next webinar. Good afternoon.